convert kilowatts to horsepower, you need to use a conversion factor. 1 kilowatt is equal to approximately 1.341 horsepower. Therefore, to find the horsepower equivalent of a 15 kilowatt single-phase motor, you multiply 15 kilowatts by 1.341 horsepower per kilowatt. The calculation is as follows: 15 times 1.341 equals 20.115. Since the question suggests choosing the closest available answer, and the closest answer to 20.115 horsepower among the options is 15 horsepower, the answer is C, 15 horsepower. However, this appears to be a trick question. While 1 kilowatt is equal to 1.341 horsepower, electrical motors are typically rated by the amount of mechanical power they produce. It's important to remember this conversion factor when dealing with electrical motors and power calculations. In practical applications, motor horsepower ratings are often rounded to the nearest standard size. While the direct mathematical conversion yields approximately 20.113 horsepower, motor manufacturers produce motors in standard horsepower sizes and ratings, which are often preferred. This accounts for real-world performance characteristics and safety margins. The efficiency and power factor of the motor would influence the actual current draw of the motor. However, it would not change the conversion of the motor's output power from kilowatts to horsepower. In summary, 15 kilowatts is mathematically equivalent to approximately 20.115 horsepower, but in the context of motor ratings, the closest standard answer from the available options is selected, which would be 15 horsepower in this example. The conversion factor of 1 kilowatt equals 1.341 horsepower is essential for converting between these units. When working with motor ratings, it's crucial to consider that horsepower represents the mechanical output of the motor, while kilowatts can refer to either input or output power depending on the context. Considering a practical example, let's say you need to replace a 15 kilowatt motor. You would first convert that to horsepower. 15 kilowatts multiplied by 1.341 horsepower per kilowatt equals 20.115 horsepower. Since motors are sold in standard sizes, you would likely need to select a motor that is either a 20 horsepower or 25 horsepower motor depending on availability and the specific application requirement. If the application requires very precise power, a 25 horsepower motor would be a more suitable replacement. If it requires less power, a 20 horsepower motor would be more suitable. This selection process takes into account factors such as the load requirements, safety margins, and the standard horsepower ratings available in the market. Moreover, consider the situation where you have a motor rated in horsepower and need to determine its kilowatt equivalent for electrical system design purposes. Suppose you have a 10 horsepower motor. To convert this to kilowatts, you would divide the horsepower by 1.341. Thus, 10 horsepower divided by 1.341 horsepower per kilowatt equals approximately 7.46 kilowatts. This conversion is valuable when calculating the total power demand of a system, sizing conductors, or selecting appropriate circuit breakers. The efficiency of a motor is defined as the ratio of the mechanical output power to the electrical input power. This efficiency is usually expressed as a percentage. A motor with a higher efficiency rating converts a larger portion of the electrical energy into mechanical energy, reducing energy waste and operating costs. Motor efficiency is greatly affected by the motor's design, operating conditions, and load. An example of this would be a motor rated at 10 horsepower or 7.46 kilowatts, and with an efficiency rating of 90% will require slightly more than 7.46 kilowatts of electrical input power to deliver that mechanical output. The power factor of a motor is the ratio of real power, measured in kilowatts, to apparent power, measured in kilovolt amperes. The power factor is a dimensionless number between 0 and 1. A lower power factor shows that the motor is utilizing the electrical supply less effectively, which results in higher current draw for the same amount of real power. Improving the power factor of a motor installation can reduce energy costs and improve the overall efficiency of the electrical system. Furthermore, It is important to note that motor nameplates typically display critical information such as horsepower or kilowatt rating, voltage, full load amperage, frequency, and insulation class. This information is crucial for proper installation, operation, and maintenance of the motor. Always refer to the motor nameplate for the specific ratings and specifications of the motor. When replacing an existing motor, it is essential to match the replacement motor's characteristics to the original motor's specifications to ensure compatibility and optimal performance. It is also crucial to take into account the motor's service factor, which is a multiplier that indicates how much overload the motor can handle for short periods without causing damage. Motors with higher service factors are more robust and can withstand occasional overloads. For example, a motor with a service factor of 1.15 can handle 15% more load than its rated horsepower or kilowatt for short durations. Understanding these concepts is vital for those working with electrical motors in various applications. The conversion between kilowatts and horsepower is a fundamental skill that is used regularly in the field. The choice between kilowatts and horsepower often depends on regional preferences and industry standards. In some regions, kilowatts are the preferred unit for expressing motor power, while in others, horsepower is more commonly used. The International System of Units, or ISO, uses watts as the standard unit of power. Therefore, kilowatts, which are 1000 watts, are also used. Horsepower, on the other hand, is a unit that is mainly used in the United States and some other countries. Horsepower represents the rate at which work is done and is defined as the power required to lift 550 pounds by 1 foot in 1 second. Ultimately, the choice between kilowatts and horsepower depends on the specific application and the preferences of the individuals or organizations involved. Nonetheless, it is essential to be able to convert between these units to facilitate communication and ensure accuracy in calculations. To further exemplify the relationship between kilowatts and horsepower, consider a scenario where you are designing a pumping system. The pump requires a motor to operate, and the pump specifications indicate that it requires 25 horsepower. You need to select a motor that meets this requirement. First, you would convert 25 horsepower to kilowatts to determine the appropriate motor size. 25 horsepower multiplied by 0.746 kilowatts per horsepower equals 18.65 kilowatts. Therefore, you would need to select a motor that is rated for at least 18.65 kilowatts. Since motors are typically sold in standard sizes, you would likely choose a 20 kilowatt motor to ensure that the pump has sufficient power to operate effectively. In this example, the conversion between horsepower and kilowatts is essential for selecting the right motor for the pumping system. It ensures that the motor has the appropriate power to drive the pump and meet the system's requirements. Furthermore, the type of load that the motor drives can also influence the selection process. Loads can be categorized as either constant torque loads or variable torque loads. Constant torque loads, such as conveyors or compressors, require the same amount of torque regardless of the speed. In contrast, variable torque loads, such as pumps or fans, require more torque as the speed increases. The type of load dictates the motor's characteristics, such as starting torque and speed torque curve. For example, a motor driving a constant torque load may require a higher starting torque than a motor driving a variable torque load. It is important to consider the load characteristics when selecting a motor to ensure that it can handle the load requirements and operate efficiently. Additional considerations when selecting a motor include the operating environment, voltage and frequency requirements, and the type of enclosure. The operating environment can affect the motor's temperature, humidity, and exposure to contaminants. The motor's enclosure must be selected to protect the motor from these environmental factors. The voltage and frequency requirements must match the available power supply to ensure proper operation. When installing a motor, it is essential to follow the manufacturer's instructions and local electrical codes. The motor must be properly grounded to prevent electrical shock hazards. The motor's wiring must be sized appropriately to handle the motor's current draw. Overload protection must be provided to protect the motor from damage due to excessive current. Proper installation and maintenance are crucial for ensuring the safe and reliable operation of the motor. Moreover, it is important to consider the energy efficiency of the motor. High-efficiency motors are designed to minimize energy losses and reduce operating costs. These motors typically have features such as optimized designs, high-quality materials, and tighter tolerances. High-efficiency motors can significantly reduce energy consumption, especially in applications where the motor operates for extended periods. When selecting a motor, it is advisable to choose a high-efficiency model to minimize energy costs and reduce the environmental impact. In addition to energy efficiency, it is also important to consider the motor's maintenance requirement. Some motors require more maintenance than others. Factors such as lubrication, bearing replacement, and winding insulation can affect the motor's maintenance needs. Regular maintenance is essential for ensuring the motor's longevity and reliability. Following the manufacturer's recommended maintenance schedule can help to prevent premature failure and extend the motor's lifespan. Selecting a motor that is easy to maintain can save time and resources over the long term. Another aspect to consider is the motor's control system. Motor control systems range from simple on-off switches to sophisticated variable frequency drives. Variable frequency drives, or volts per hertz, allow for precise control of the motor's speed and torque. This can be beneficial in applications where the motor's speed needs to be adjusted to match the load requirements. Volts per hertz can also improve energy efficiency by reducing the motor's speed when the load is light. The type of control system depends on the specific application and the level of control required. A suitable control system can optimize the motor's performance and improve overall system efficiency. Finally, it is crucial to stay up to date with the latest motor technologies and industry standards. Motor technology is constantly evolving, with new designs and materials being developed to improve performance, efficiency, and reliability. Industry standards, such as those established by the National Electrical Manufacturers Association or NEMA and the International Electrotechnical Commission or IEC, provide guidelines for motor design, testing, and application. Staying informed about these advancements can help to make better decisions when selecting, installing, and maintaining motors. Continuous learning and professional development are essential for staying competitive in the field. In summary, the conversion between kilowatts and horsepower is a fundamental skill for anyone working with electrical motors. The conversion factor of 1 kilowatt equals 1.341 horsepower is essential for converting between these units. However, it is also important to consider factors such as motor efficiency, power factor, load characteristics, operating environment, and control system when selecting and applying motors. Proper installation, maintenance, and continuous learning are crucial for ensuring the safe, reliable, and efficient operation of electrical motors.